Hello everyone, and welcome back to the ACSL Recursive Functions. Today, we are doing some of the sample problems that I introduced last video. So let's get into it. So let's do the sample problem 1 first. So it says find g of 11 given the following. So you return g of x minus 3 plus 1 if x is greater than 0. And you return 3x if x is otherwise. So if it's equal to 0 or less than 0. So we can start by writing the equation down. So I can erase the screen here. So g of x, curly bracket, and then it returns g of x minus 3 plus 1. G of x minus 3 plus 1 if x is greater than 2 or 0. And then you return 3x otherwise. So you start with g of 11. So g of 11, the way you solve this is equals. So since x is greater than 0, you return g of, so 11 minus 3 is 8 plus 1. And then which will equal so g of 8, you do the g of 8, so you slowly narrow down. So g of 8, since that's still greater than 0, you return g of 5 plus 1, and you return, when you do g of 5, you return g of 2 plus 1, and since that's still greater than 0, you do g of -1 plus 1. So now the g of -1 is less than 0. So g of -1 equals 3x, so that's -3. And then you just go backwards because you have to add the 1. So that's equal to, since g of -1 is equal to -3, you just plug it in. That's -2, plug it in, -1, plug it in, 0, and then 1. So the answer will be 1. And you see on the websites, they do the same things. So they slowly narrow down and they get g of -1. And then they just simply plug it in and then get back to the top to get to g of 11, which is what you're looking for, and that's equal to 1. So very simple. Let's move on to the next. So find the value of h of 13 given the following definition of h. So h of x, so that's h of x minus 7 plus 1 if it's greater than 5. X when x is between 0 and 5. H of x plus 3 when x is less than 0. So we can clear this and write down the definition. So h of x, curly bracket, h of x minus 7 plus 1 when x is greater than 5. When x is greater than 5. And x when x is between 0 and 5, and you return h of x plus 3 when x is less than 0. When x is less than 0. So that's, now we wrote down the rule. Now it should be easier to do. So now you find the value of h of 13. So h of 13 So h is greater than 5. So you return h of 13 minus 7, which is 5 or 6 plus 1, as it says here. And h of 6 equals 2. Since it's still greater than 5, you return h of negative 1 plus 1. And h of negative 1 when it's greater or less than 0 equals x or h of 2. And since that is between those two, you can just return 2. So then you plug it back in. So h of 2 is 2 equals 3 equals 4. So yeah, it says the solution is 4 because you go backwards, and it shows the rules you do. So top rule. So since 5 is greater than 5, x is greater than 5, and then x is greater than 5, and then x is less than 0. And then when you add 3 to it, you get h is 2, which is between 0 and 5, and you return 2. And then you can just work backwards to get 4. So that is the way you do it. And I'm going to erase it. So for this is an extra challenge for the people who want to solve this. It is consider the following recursive algorithm for painting a square. So given a square, if the length of the side is less than 2 feet, then stop. Divide this square into 4 equal squares and paint one of those 4 small squares. Repeat for each of the 3 unpainted squares. So, so if this algorithm is applied to a square of 16 feet, how many feet will be planted? So first we need to dissect this. So you find the length. So if less than 2 feet, then stop. So right now 16 feet, so you don't stop. So the square, if we draw a square, 16 by 16, and you will divide the square into 4 equal size squares and paint one of them. And repeat this procedure for each of the 3 unpainted squares. So you move back to here and you redo it. So it is a recursive function. So you split this into 4. So then each of them is 8 by 8. And you paint one of these. And then you split all of these and you paint one of them. So then each of these is 4 by 4. And you keep on doing it until it's 1, because you start at 16, divide by 2 for each of the sides. That's 2, 8, and then you divide by 2 again until it's less than 2. So then that's 4, divide by 2, 2, and then divide by 2, and that's 1. So that's 1, 2, 3, 4. 4 different algorithms that you're going to do, or 5 different algorithms. 4 algorithms. And you define how many square feet will be painted. So So you have to check. So the first time you fill it, you will have 64 feet. And then when you do it again, you add it up. So these are 4 each. That's 4 by 4. So that's 16 times 3 plus 16 times 3. And then plus, so that's divided by 2 again. So that's 2 times 2. That's 4 times 3. Or no, 4 times 3. So that's 4 times 9. 4 times 9. And then plus 1 times, that's 9 times 3, 27. So then in total you get 64 plus, so that's 48 plus 36 plus 27. And then you'll get 100 plus 75. So that's 175. And when you see the answer will be 175. So they did it a different way than I did. We can check the solution. So the way I did was I just added up each painting. So I found how many steps it takes. So then I found the first step is 64 square feet of paint plus, and then how much paint are in each square, which is 4 times 4, which is 16, and then multiply by that many squares, that's times 3, and then I counted each time, so that's 3 more squares, and then that'll be 9 squares in total that are painted, and then it'll be 27 squares. And then you just add it all up together and you'll get 175 square feet. The solution they have is, in the first pass, we get 4 squares of side 8. And then 1 is painted and 3 are unpainted. So then next, we have 3 times 4 squares of side 4. 3 are painted, so the area is 3 times 4 to the power of 2. Same that I did, except for I did 16 times 3, and 9 were not. And then 9 times 4 squares of side 2. So that would be 9 times 4 um, so that'll be 9 times 4, which you can simplify to 9 times 2 to the power 2, and 27 are not. So then next you'll have 27 times 4 squares of side 1. So that'll be 24 times 1, or 27 times 1. So then you add them all up to get 175. You can go to the website to read it if you still have questions. And there are online resources like videos to help you. So thank you for watching this video, and we'll see you in the next category.